So we're going to prove triangle ABC is congruent to CDA. ABC, CDA. Now, it doesn't explicitly tell us what's given, but it is marked in the picture. So if it's marked in the picture, in the diagram, we can write that it's given. Because it's given to us, it's just not given in words, it's given in symbols. So we know that angle ADC is congruent to angle CBA. Because it's marked in the picture, that is given. We also know that AB is parallel to DC. AB is parallel to DC, that was also given. Since we have parallel lines, we're looking for alternate interior angles. So you trace the parallel lines with the transversal, and you get some alternate interior angles right there. Those angles are BAC, congruent to DCA, because they are alternate interior angles. So we need something else. We've got the reflexive property right here. AC is congruent to itself. Reflexive. So now to prove the triangles are congruent, we have ABC and CDA. They are congruent because we have an angle, another angle. The side is not in between, it follows them. So it will be angle, angle, then the side. That proves the triangles are congruent. ABC is congruent to CDA. Given BC is congruent to DC and AC bisects angle BCD. Complete the statement. Triangle BAC is congruent to triangle. We need to fill it in corresponding order. So since we can see that these are congruent with a little reflection over AC right there, A is going to match with A, B matches with D, and C matches with C. So we said B matches with D. We start with B, you have to start with D. And then we said A matched with A, so if A is next, A goes next. And then C matched with C, so if C was last, C is last there. You have to name them congruent in corresponding order. So now we'll complete the proof. BC was congruent to DC, that was given. AC bisects angle BCD, that was given. BCA is congruent to DCA. That's the definition of an angle bisector. It cuts the angle in half. And now we need the last two lines. So in order to prove the triangles are congruent, we need one more thing. We have a side and an angle. We get AC is congruent to itself. That's the reflexive property. And now we know the triangles are congruent because of side, angle, side. Given that AT is a median of triangle CAR. So if it's a median, that means that T right here is the midpoint, which means these two sides are congruent. Midpoint cuts it into two congruent pieces. So CT and TR, we just said that they are equal, so we're going to set them equal. 7x plus 2 equals 9x minus 4. Since that's the midpoint, the two sides are equal, set them equal, and solve for x. Subtract the 7x, get 2x. Add the 4, you get 6. Divide by 2, so you get x equals 3. It said solve for x. There it is. Determine the value of y that proves the triangle is isosceles with base BC. So if it's isosceles, that means with base BC, that means these two sides are congruent. Also, these two angles will be congruent. The isosceles triangle theorem says base angles are congruent. We also know that the three angles add to be 180 degrees. So we're going to take that first. We're going to solve for x because we know that angle B is congruent to angle C. Instead of worrying about what that says, we're just going to take the 4x plus 48 and use it in both angles because the angles are congruent. So 3x minus 15 plus 4x plus 48 plus the other 4x plus 48 equals 180 because the three angles of a triangle always add to 180. So we're going to combine like terms here, 3x plus 4x plus 4x, so that's 11x. And then negative 15 plus 48 plus 48, it's 81. Subtract the 81, so you get 99 equals 11x. So x equals 9. That's not what the question said. It said determine the value of y. So if x equals 9, then 4x plus 48 would be 36 plus 48. So this angle is 84. So that means 9y plus 21 has to equal 84. So you subtract the 21, you get 9y equals 63. So y equals 7, and that's what it asked for. Which side of triangle ABC is congruent to RP? So here's RP. It looks like in order for these to match up, we'd have to translate, we could translate RP up, and it would be up here. Here. So if we translate it up, it looks like that. That now looks like RP would match up with CA. And then which series of rigid motions supports your conclusion? I already started that. We can translate RPQ, translate it up. We moved it up 6 units. We didn't move it left or right at all, so we went with the vector 0 and then just up 6. And then to get it to match, we would then reflect over the y-axis. And then they match up completely. So our verbal evidence would be this little sentence right here. And the visual evidence is just plotting our points here, and then you can see the reflection. We're going to construct a triangle such that OM is congruent to OP. That means it's going to be an isosceles triangle. To construct an isosceles triangle, you start with a line segment for the base. Then you get your compass. Put it on one endpoint of the base that you made, stretch it more than halfway. Draw a semicircle. Do the same thing from the other endpoint. So that you can draw the perpendicular bisector. Any point on that line that we just drew will form an isosceles triangle. So I'm going to go all the way up to the top. And now we've got this isosceles triangle. Now we have to be careful to how it said though. Label it. It said OM has to be congruent to OP. So this must be OM and then OP because these are the congruent sides. So for this, we are trying to prove the base angles are congruent. We're trying to prove angle M is congruent to angle P. And what we currently know is OM is congruent to OP because that's what we had to start with. We also know that we can call this point whatever we want. Let's call it, sure, we'll call it F. And we know that that's the midpoint. We know that OF is the bisector of MP. Because we constructed the bisector. It's given because that's what we constructed. We know it's true. So if it bisects, that means that MF is congruent to PF. That's the definition of bisect. So we've got these sides are congruent. And we also know that OF is congruent to OF because that's the reflexive property. So the two halves of this isosceles triangle are congruent. That forms triangle MOF and POF. We know that they're congruent because we have all three sides congruent to all three sides. That's side, side, side. But that's not what we were trying to prove. We're trying to prove the base angles, which are angle M and angle P. Since the triangles are congruent and those are corresponding, that means that they are congruent because of CP, CTC, which means corresponding parts of congruent triangles are congruent. And that's it.